All right, here we are back again with Bert and Ernie and their test scores. And I think a pretty good way of actually looking at this idea of variability, consistency, inconsistency, what have you, is to actually look at a graph of these scores along a number line. So that's what I've done here. I've placed their test scores. I put the minimum down there at 60 and the maximum up here at 100. And then I just placed kind of their heads along the graph. Now, you can see pretty quickly, actually, when you put them on a graph like this, that Bert's scores are more spread out than Ernie's are. One thing that might not be as obvious for Bert as Ernie is where their averages are on these graphs. We calculated them both to be 81. Bert's might be a little bit hard to see, but here it is, just like Ernie's. But even though their averages are the same, we can't ignore the fact that Bert's scores stretch far from the left to far to the right, where Ernie's are kind of packed in here pretty close to the average. Let's take a look at measuring that now. One of the most straightforward measures of variability is called the range. It's got a really agreeable formula. You take the high value and subtract the low value, and that gives a distance of how far apart the data is. So for example, for Ernie, his high value is 83 and his low value is 79. That means he has a range of 4 because 83 minus 79 is 4. Bert's range is greater. He's got a high score of 100 and a low score of 61, which means he has a range of 39, which is roughly 10 times the range of Ernie's. So one thing you could say is that, using the range, Bert is 10 times as variable as Ernie. The range we'll see here and there as we kind of go through Math 243 together. But what I want you to think of right now is there anything the range might hide from us? I want you to hit pause here and think about that. And once you've got an answer, scratch it down and then keep going. All right, so here's the data that we've been playing with. I'm going to change it a little tiny bit. And when I say a little tiny bit, I mean I'm going to change all of Bert's scores. So I've taken Bert's scores and I've shoved them up to the top. So now his lowest score is a 96 and his highest score is 100. That means that now Bert and Ernie have the same range. So what does it mean if two data sets have the same range? Can you say they're the same in any way? I mean, yeah, they're the same through the lens of variability, but now they're also very different. How are they different? Well, it doesn't take too long to figure out that Ernie's average is still 81, Bert's new average is 98. So although Bert and Ernie both have the same range now, which means they both vary the same way, they are no longer the same kind of student. And I think that is where we need to head next. We need to head into an exploration of how to connect the measures of center to the measures of variation. But I think we'll hold that exploration till tomorrow. This is a good place to stop and kind of let the idea of general variation wash over us. You can take a look at the homework after this. We'll definitely tomorrow, in day 2 of variation, look more closely at how to link measures of center to measures of variation. You've actually done some of this kind of before in previous classes with me, if you've taken a class with me before. And the reason I want to stop is it's going to be mathematically dense tomorrow. It's not going to be mathematically difficult. Because when I think about the math we're going to do tomorrow, it's going to be like adding, subtracting, raising things to second powers, taking absolute values. Nothing major. But it's going to be a lot of arithmetic and a lot of questions I'm going to ask. And I just think it's a good place to stop for today before we get into that. Because you've probably never thought about variation before. So let's think about it globally here. You've been thinking about averages ever since you were knee-high to a grasshopper. Soon as you know how to add and divide, they teach you how to take an average. I like the fact that we look at it more deeply, but that's kind of why you're in a stats class. But also, let's pause here, look at the general idea of variation. Got some good homeworks for you here. And then tomorrow we'll come back and we'll tie variation inextricably into center.